Hello everyone, I'm Segun Lajitomobi, your friend. Today I want us to look at how to plot daily, monthly, and annual time series data using our, our software. Let's go straight into business. Open your R Studio and let us set our working directory. We shall still continue to make use of COVID-19 folder. That's COVID-19 folder. I open it. So you come to File to see the content. Remember in our last class, we have a data set on COVID-19 in Nigeria. So this is the data set. So let us import the data set quickly. Fine, so let's import it. Good. So here we have COVID-19 Nigeria data. So let's go back to our script editor. Let us load all the packages that we are going to use. For this illustration, we are going to be making use of 4 different R packages. So we have library. The first one is zoo. I'm going to be using zoo for plotting daily data. Then we are still going to make use of dplyr in order to manipulate our data sets to suit whatever we want to do. Then we will need ggplot2 in order to draw elegant graph. ggplot2. And we are going to use an extension of ggplot2 called gg45. gg45. Okay, so let's run all the packages. Fine, so we all have the packages. Oh, it said error here. Okay, that's because when we highlighted, we omitted L. So let's do it again. So fine. So we're going to start by illustrating the number of affected cases in Nigeria on a daily basis and drawing the graph. The starting point is to define the daily data that we need. So we are going to define it from when to when. So let us call it case that. That is the name of the new data set we would like to generate. We need zoo. So we have COVID, Nigeria. Dollar will give us all the variables in the data set. But the one that we want to draw the graph is cases. Good. So we select cases. So let us define the sequence. So we have seq from equals, so we say as dot date, so we now put in quotes our starting date. So let's start from 2019 12 31, which is the first day on our data set. So comma, Now we have from, then we have to have to. So to equals, again, as dot date. So let us now define the end date. So the last day on the data set is actually April 9, 2020. So we now have 2020 0409. Good. So comma. So by equals to 1 because it's a daily data, day by day. So we want, what we are saying is that we want the data to run from 2019 December 31 to 2020 0409 on daily basis. So let us run it. Run. Fine. So now we have our data set. To plot it is very, very straightforward. We use autoplot. Autoplot. This autoplot here. What do you want to plot? Case that. That is our case that. So let's define our X label, X lab. So I want to call my X label days. First number of days. It's day to day, so that's day. Then let me define my Y label. So that's, let's say, Y lab. Now my Y lab is actually number. So that's, let me put number. Good. So let's run it. So you can see, let's zoom in so that you can see it clearly. Yeah, so you can see this is actually showing the data set from December 31, 2019 up to April 9, 2020. So this, the elegant data sets we are talking about. And you can just copy the image, then I'll save it in Word. Another thing you can do, if you don't want to copy, you can come here and see export. So you can export it as image, you can export it as PDF, or if you want to export it to your Word, you say copy, then you say copy plots, and you can even adjust the width, the height, and so on. Yeah, let's say I want to adjust this to something like 300, and let me adjust this to something like 500. Yeah. So you now say update preview, you can see. So say copy plots. So come here. Okay. So let's wait a bit. Okay. It's wasting our time. Okay, yeah. So you have your graph here. Yeah. Fantastic. That's great. So that is how to draw daily data. Now let us illustrate how to plot monthly data sets. To plot monthly data sets, let us think of a country where we have our COVID data that runs from um, December, January, February, March. Let's think of China. So, which means we need to import our COVID-19 data. So let's bring COVID-19 because it is in COVID-19 that we can actually extract China. COVID-19, right? Yeah, this COVID-19. Let's import COVID-19 data. Fine, so these are our COVID-19 data sets. If you look at it here, if you say month, we are 33333 because it's daily. So we really need to summarize again these data sets into monthly sum. So we want to get the total number of cases, for instance, for various months and for various countries. So how do we do that? So let's go back to our script editor. To do that, let us call it month dat. So that's month dat. That's our monthly data set. So we have COVID-19. Now don't forget, we have percent. We call it, that is chaining operator in R. But in layman language, it's better we look at it as the word then. That is, I have COVID-19, then what do I want to do with it? So COVID-19, percent greater percent. So what do I want to do? I want to group by. So I want to group it by months. And I will need the country, which is the code. So what do you want to do again? That is percent greater percent. Now I want to summarize. So I say summarize. Let's say summarize underscore each. So I define my function, FUNS, pick it here. So what do I want? I need the total. No, here you can have the total, the mean, the median, whichever. But now let us look at the total. The total is sum. So comma. Now let us look at cases. So let's run it. Fine. Don't worry about all those red letters. So the next thing we want to do is to now get the data, the monthly data for China. So to get the monthly data for China, let us call it COVID CHN. That's COVID for China. So then, which means we have to filter our monthly data. and extract China from it. And that's very simple to do. So you have month dot now, month dot, then percent greater percent. So what you want to do? Filter. So we have code equals. The three-letter code for China in the data set is CHN. CHN. So let's run it. So fine. So we now have our China data. So our interest is to draw a monthly annual data, annual time series data, and plot it. So let us define, let's say China. Oh, let me use small letter. China. So I convert it to time series. Time series is TS. It's very straightforward. So I need COVID China. COVID China. Dollar. So I need cases. This one I need. So start, since it's monthly, start equals, let's say C. Now the starting point is 2019, comma 12. That is December 2019. Now you just say frequency. Since I'm interested in monthly, I will just put 12 here. Straightforward. Very simple. So run it. Fine. Then to draw the graph, I use my autoplot. So say autoplot. China. Then you can now add the X label. Let's copy it from here to save time. The X label, that's copy. So you just add it here, paste. Don't forget plus. Yeah. So let's run it. See what. Yeah. So we can see clearly now that the peak for the number of infected cases in China occurred around January. And from there, you can see a steady decline in the number of infected cases. And in China, we can see that as of April, it has actually gone down. So that's wonderful. So the last thing I want to show us is plotting annual data, which is the easiest to do. So for annual data, we cannot use COVID-19. We all know that uh, it's not up to 1 year, not to talk of having it on a yearly basis. And we don't even pray that it should be like that. Our prayer is that by latest, the end of this week, everything called coronavirus should be history. across the world in the name of Jesus. So let us use another data set. I want to use a data set I got from IMF World Economic Outlook on Nigeria. So this is where I got the data set, International Monetary Fund World Economic Outlook data, October 2019. So let's look at the data set. So let me import it. So let me import it so we look at the variables. So we have year, we have per capita GDP, we have inflation rates, unemployment rates, and the population in millions. And we have data from year 2010 to 2019. So here we are. So let's come here. So let us plot the graph for rate of inflation, which means we have to first convert it to time series because that is in data frame. So to convert it, we have inflation. Let's call it inflation. You can call it any name of your choice. So, sorry, let us have it here. That's inflation. I call it inflation. So to convert it is TS. It's always very simple to draw monthly and annual data. So the name of my data list, WEONIG. If I click on dollar, it's going to show me the list of the variables. I want to draw the graph for inflation, so I pick inflation. Then I have start. So start equals, that's my starting year now. So my starting year is 2010, comma. Then frequency. Frequency, since it's an annual data, is just one. So it's very interesting. So very straightforward, very simple to understand. Run it. Fine. So in order to plot it, don't forget, just say autoplot. Autoplot what? That's inflation. Yeah, so let us add the X label and our Y label. So let's stop here. Let's add it. Paste. Yes, the X label cannot be day now. So it should be year. So don't let us forget that. And our Y label cannot be number, it's in percentage. So let's call it percent. Something like that. So let's run it. Wonderful. So it's very straightforward to do. So but let's make some kind of correction here. You can see that here you have 2010 0, 2012.5, and so on and so forth. So if you want to correct it, which means you have to redefine your x-axis scale, and that is what I want to show us now. how to do it. It's very straightforward to do. So to do that, let us call the plot, let's call it plot 1. Let's be, because we want to add one more thing to it. So now we have plot 1 equals now plot 1, that is this plot, plus, yeah, anyway, doesn't matter, that's plus. So what you need to add is scale underscore x continuous, because it is x-axis that we want to adjust the scale. So we say breaks, because we want to define it. Breaks equals so you say sequence, want to define the sequence. So what is sequence? I have 2019, 2010, sorry, 2010, comma, 2019, comma, by, at least to get, to remove this 0.5, if it's, because this is around 9 years, so by equals to 3, I think that should change it. So let's run it and see. Oh, say plot 1. Okay, it's because we did not plot it from plot 1. So let's plot it from plot 1 up. Run it. Good. So, and if you want to look at your results, since we have given it a name now, you have to put plot 1 here before the graph can be seen clearly. Fine. We have seen now 20, 10, 20, and so on and so forth. Yeah. So the last thing I want to show, what if I want to plot the inflation and unemployment together in one graph? So then you have to define the second plot. It's very, very simple to do. So let us define the second plot. Let's call it plot 2. So which means our plot 2. No, sorry, we first need to define unemployment. So let's call it unemployment now. So we have the time series. So we have WEO Nigeria. That's dollar. So this our unemployment rate here. Comma. So say starts equals 2010. Then frequency equals to 1. So let's define it. Let's run it. Good. So we need to combine inflation and unemployment together as a data set. So, and that is what we are going to do now. So let us call it maybe new plot. You can call it any name you like. So you use cbind because I'm combining inflation. We have inflation, comma, then I have unemployment. Good. So I run it. So what I want to plot now will now be new plot. So I will say autoplot, autoplot, new plot. Let's run it and see. Yeah, so we now have the two. Don't forget, you can just use plots plus k this in order to correct the x-axis here. Now where I have inflation and unemployment separately, but if I want to combine the two, it's very straightforward to do. Just call me and say comma, then you change the facet. Say facet equals false, because I don't want two faces. I need one. So run it. So let's fine. So and okay, let us call it plot 3. Plot. Let's call it plot 3. What can you notice here? This is called plot group. I may want to change the name to something else. So in case you want to do that, it's very straightforward to do. So which means, let's try to do that. So we have plot 3 equals plot 3, because I want to do something. Then plus, say, scale underscore color underscore color discrete. Color discrete. This is the one I need. So the moment I have this, I will now say name equals, then I give it a name I want. What do we give it? We have inflation and unemployment. So let's see. Let us give it group. Yes, I don't want the word plot to be there. Group. You can give it any name of your choice. That's yeah. So if you do that, I run it. Oh, sorry, you said plot 3 not fine, so which means I have to pick it from plus 3. Good. So now I want to look at my plot 3. Say plot 3. So you run it. You get fine. You can see now the name has changed. So let me add this plus k so that I change it to something that makes sense. Fine. Copy. Yeah. So run. Fine. So this is how to plot graphs, daily, monthly, and yearly data. I hope it's very clear, and I hope we can repeat it. It's interesting. So let me show us, peradventure, one more thing before we round up the class today. In case the font size of your house studio is too small or too big and you want to make adjustments, what you want to do, you come here, Tools, you come to Global Option, then you click on Appearance. So you see I'm using size 11, and you can change it so to switch you. So that is it. So let me zoom this so that you can zoom and see clearly the graph. Yep. Fantastic. So thank you for listening, and I hope you join me again when we are looking at another topic. Enjoy your Easter break. And please let us not forget to pray for healing of those people that are affected by coronavirus, and to ask God to terminate the plague across the world. In the name of Jesus. Thank you very much.